Hello everybody, Chris here, and in this video I'm going to be giving all of you a quick crash course on Unity 2D for building a top-down style game. So in this video I'm going to be using this asset pack Mystic Words, which you can find on itch.io. I'll put the link in the description at game-endeavor.itch.io/mystic-words. So there's a free version of this, and that's what I'll be using for this little demo, and you can just click on the download button to go ahead and grab that. So once you have this or any other art asset that you want to use for this project, let's go ahead and create a new project in the Unity Hub. So you can see here I'm using the 2022.1 version of Unity. If you're using a different version, it probably won't matter too much, but just be aware that's the version I'm on. So let's go ahead and click on a new project here. And then I'm going to be creating a new 2D project just using the standard built-in renderer to keep things simple for now. So we got to choose a storage location for where we're going to save our project. I'll go ahead and navigate to that. So I have a little folder here called tutorials. I'm going to select this folder and I'm going to rename the project. So I'll call it top-down 2D crash course. And let's go ahead and hit create project. So it'll take a minute, but go ahead and wait for this loader icon to complete, and then we'll get started. So our project is opened up. The first thing I'm actually going to do here is create an art folder, and I'm just going to bring the art assets that we talked about earlier into this project. So I'm going to right click down here in the project window over here, and then do create, and then folder. So I'll call this art. I'll double click into it, and now in your file explorer, go ahead and extract and find the sprites from your art asset pack, the Mystic Words. So I'm going to bring these sprites into the art project right here. Also rename this to be Mystic Woods, just make it a little bit more clear what it actually comes from. And now we can go ahead and explore the folders and see the characters which we have brought into the project. So for any sprites that you're going to be using for a pixel art game, the settings you're going to want is going to be to take the filter mode and turn that down to point filter, and then the compression down to none. That'll make it so that the pixel art looks crisp and that there's no anti-aliasing or anything like that. So the next thing you'll notice if you look at these sprite sheets, and I'll go ahead and expand them with this zoom bar in the bottom right, is that there are multiple sprites inside of one sprite sheet, which means that you need to take the sprite mode over here and change it from single to multiple so that you can split the sprite sheet into individual frames. So let's go ahead and click on the sprite editor now. I'll hit apply to apply any unsaved settings over here. Now you can see the sprites for our character in the game. So we need to slice this based on either the number of rows and columns or the size of each individual frame. So I'm going to slice based on, let's go to cell count, because I don't actually know exactly how big these frames are, but we can pretty easily count how many rows and columns there are. So let's see, 1, 2, 3, 4, 5, 6. So we have 6 columns, and then we have 1, 2, 3, 4, 5 rows. So let's go ahead and grab that, hit slice, and get out of that editor. So you notice that the areas that don't have any actual sprites are excluded from here. So when we hit apply, we're only going to get frames that properly have a sprite, which is what we would want anyway. So let's go ahead and hit apply here and close this out. Now you'll notice that you can expand this player sprite sheet by clicking over here now, and you'll see all of the frames individually numbered for our sprite sheet. Now let's do the same thing with the slime. So I'm going to change sprite mode from single to multiple, filter mode from bilinear to point, and compression to none, and hit apply. Okay, now let's open up the sprite editor and do basically the same thing. So let's slice based on number of columns. So I count 7 and then 5 rows going downwards. So if we do 7 columns here, and you can of course see these red lines and just kind of confirm that it looks correct. Let's hit slice and apply. Close out the sprite editor, and now you can expand the sprite sheet and see all of your animation frames. So let's go ahead and take our first animation frame, player 0, and bring it into the scene. So this will create a new game object inside of our scene. So this will create a new game object inside of our scene. So a game object is going to be built out of multiple components. Components like the transform component you see over here, or the sprite renderer, which is automatically created for us when we bring a sprite image into our scene window over here. So the sprite that's being rendered, if we zoom in here, is of course that player 0 frame. As you might imagine, a sprite renderer and a transform is not really enough to create a moving, working game character, but it is the start. And in the newer version of Unity, when you click on a sprite in your scene, it's going to be glowing orange, so you know which one is selected. It doesn't actually have that orange around the border in the actual game. I mean, you can see how it looks if we go over to game view. So let's go ahead and turn this player game object in the scene into a prefab. A prefab is just a reusable game object that all the data for it is stored in your project. So you have your core template, the prefab, and then you can create instances of that game object anywhere you need it. So you might spawn a player into multiple levels, but you only have to have the base data for that player stored into one prefab. It's really useful if you're doing things like monsters, which of course you would have more than one of inside of your game. So first, let's change the name of this game object. In the inspector in the top right, make sure it's selected in the hierarchy on the left. So let's go ahead and change some stuff about the game object. In the left for the hierarchy, make sure that you click on player 0 and that your character is highlighted here. Now let's go to the inspector on the right so we can edit the details. I'm going to change the name of the character to player. The tag I will change to player as well. So the tag is just a descriptive string that can describe what type of object it is. So the built-in for player is perfect here. So if we ever needed to identify that a character that was doing an action was of a player tag, then we can use that string and check against it. The transform, because we're going to turn it into a prefab, I'm going to change the position here to 0 and 0, which will put us in the center of our scene. That's important for prefabs because for prefabs, you don't want to kind of predefine its location because you don't know where you're going to put it in your scene. So anything you don't know, you don't want to have customized. For a sprite renderer, that's fine as it is. So let's turn this into a prefab now. So on the project window, bottom left, I'm going to create a new folder here. Right click, create folder. I'm going to call it characters. I'm going to jump into here and maybe we'll separate each character into its own folder because when you're building a character like an enemy or player, they're going to actually have many different things that actually build that game object. So you'll have animated components. You might have custom scripts that define how the character works, and you'd have the prefab itself. So having separate folders makes sense. So I'm going to right click here, create a new folder, and I'm going to call it player. Let's jump into that folder, and now I'm going to drag the player game object into this project. So just left click, hold, drag and drop it in here, and now we have a prefab. So we know that this character now is linked to a prefab because it is blue in our scene, and we can click in here to open the prefab. So the difference between editing the prefab and editing the character in your scene is that when you edit the prefab, it affects every character that is instanced from this prefab. But if you change a detail about the character in the scene, like let's say the position, this is only going to affect this individual copy of that character. So although the position here is set to 2, if I click on the prefab, you can see the prefab's default is 0 for the X position. So now that we have our prefab, another problem in terms of seeing the game, if we go over to game view at the top, is that the characters are way too small. So our camera is set up for bigger graphics than this. So what I can do is click on the main camera in our scene and change the size to 1. That will be a huge start on getting things to be more in line. Let's click on player again, and I'm going to change the position to 0, kind of center it in our scene. So one setting I generally change when I'm looking at the game view is for a pixel art game, I would change it from free aspect to something like 16 by 9. If I plan for my game to be always in 16 by 9 resolution of some kind, then this will help me make sure that it looks correct whenever I'm building the game. So we can switch between scene view and game view, and it's important to make sure that our character looks correct here. So another thing you're going to want on your camera for pixel art games to make sure that all the pixels always look smooth is to add a component and then choose pixel perfect camera. So pop that in there. And then I'm also going to check upscale render texture. So if we actually display the game at a higher resolution than what it was built for, we just want to take our characters and scale them up to the actual screen size. So let's go ahead and check that there. And if you don't like this blue background in your game view, you can of course change the background to a different color. So I've been liking to make it something like a gray for right now. Of course, we're going to be taking the tiles from the art pack and using it to actually build a proper background. that we can go ahead and play on. So let's kind of work on that now. So back in the scene view, let's go to our scene hierarchy. I'm going to right click over here and I'm going to choose 2D object tile map, and we want rectangular. So this will create a grid with a tile map underneath it. So in your game scenes, you can have multiple tile maps, which is often needed if you need to have different tiles render with different settings, such as their sorting position, or whether they have a tile map collider attached to them or not. So the colliders will allow tiles to participate in collisions, and if you don't have the tile map collider, then your character would be able to walk right through it. Sometimes you want that, and sometimes you don't. So one thing you can tell is that there's now a grid, and the grid is probably way too big for this art asset pack. So I'm going to click on grid, and I'm going to change the cell size to 0.16, and then 0.16 for Y as well. I think that's probably what this pack was built with. So we'll try that for right now. And now we need to create a tile set from our art that we can use to draw the tiles into these squares. So open up Window, go down to 2D, and then choose Tile Palette here. So this window will pop up. I like to put it over by the inspector. So as a different tab you can switch between, you can just drag and drop your windows. And we need to create a palette from the artwork. So let's open the artwork and make sure the settings is correct first. So art and then Mystic Woods. Let's go to the tile sets and let's sort with these planes tiles. So I'm going to go back to the inspector in the top right. I'm going to change sprite mode to multiple, filter mode, point, compression, none, and apply. And now let's edit this sprite. So let's slice it. And this time I'm going to do grid by cell size. I'm going to try 16 by 16 since I think that's the size of these sprites. And as far as I can tell, that is correct. So I'm going to slice now. And just like before, areas where you don't have any information are going to be ignored. So let's apply the slicing here. And now we have the individual tiles, but we need to put those on the palette so that we can actually use them. So in the top right tile palette editor, click on new palette. And I am just going to call this Mystic Woods because I will bring multiple of these images into the same palette to use to draw from. And then let's click on create. Okay, don't think we need to change anything else there. So this is going to default creating the palette into the folder where the art asset is into. So I am actually okay with putting it in here. So I'll click choose. So here is our tile palette prefab. The next thing that's going to be happening is creating a bunch of tiles that exist within this tile palette. So I want to put those into a separate folder because this is a lot of tiles and I don't want them to flood this folder. So I'm going to right click and create a new folder. I will call this tiles. And now to create the tiles, let's drag the planes image into the tile palette on the right. You can place it anywhere. And if you use middle mouse, scroll out, you can see a little better the grid that you're putting it all on. And let's let go. And now it's going to generate tiles into a folder. So I'm going to choose this tiles folder, choose, and just give it a second to create the tile assets for all of those tiles. So now if we click into here, we can see the tiles assets. But what we really care about is the tile palette that exists over here in this window. So now you can click on any of these tiles and use it to start drawing on your tile map. So if we look at here, you can see that we are missing the grass tile. So I'm also going to grab the grass, the fences, the decor 16 by 16, but maybe not the 8 by 8. Since this is a 16 by 16 tile palette, I might want this on its own separate palette. But let's grab these three after changing the import settings and put them into the tile palette. So I'm going to click on grass. Or actually, really, if we want to save time, let's select all three of these. So I'm going to left click on grass, hold shift down, click on fences and decor. And now we can change the settings for all of these at once. So let's change filter mode to point, compression to none. And I'll choose sprite mode to multiple, though for the grass that should technically be single. So I'm going to hit apply here. And now I'll click on grass and change that back to single as well. So because this is a single tile, we just need to go to the tile palette and put this in somewhere. So I'll put this right here. And let's save this grass tile into the tiles folder. Next, let's click on fences, go to inspector, and let's slice this sprite sheet. So I'm going to go to slice. Let's do 16 by 16 again. Hit apply. So now we have individual squares for each of those tiles. Let's click on decor 16 by 16 and let's slice this as well. Okay, as you can see, only the top and the bottom actually have information here. So those are the tiles we're going to get. Okay, now let's click on Tile Palette. Let's bring the fence in anywhere that is blank. So I'll put that in there. Save the tiles into the tiles folder. So now let's take the fences image and bring all of the tiles over here to the Mystic Wards tile palette. Drag them in there. Okay, and let's go ahead and, okay, tile sets. I'm going to choose this tiles folder. So you might have to go back and then back in, but yeah, choose the folder, generate the assets. Okay, we can see them all pop in here. And now to finish things off, let's take the decor 16 by 16 and let's pop it in right over here to the right, and then choose the tiles folder to generate the tiles. So now we have all of the ground art assets that we're going to need inside of this. So we can basically start drawing our grid. So I'm just going to start with the grass tile. So I'm going to click on the grass tile. It's going to be in paint mode over here. I'm going to left click somewhere on the grid and add these tiles in. If I drag a box kind of like this, you can fill it in quite easily by using the paint bucket tool. So that's G on the keyboard, or you can click over here and then fill that in. We'll see one problem immediately, which is that our character is now rendering under the tile map. So there's different ways to handle that. One way that I think is pretty easy to understand is to click on your tile map and then change the order and layer and give it a negative value. So your player is currently set to a 0 order in layer. So if we change the tile map to be a -5, then the player is going to render on top of that. Okay, now let's click back on the tile palette and let's draw a little more. So let's add some sand tiles in. I'll just kind of create some random regions where we want things to be a little bit different. And then you can add the tiles which would serve as the border between the grass and the sand. So I'll add that in there. So let's start with the easy ones, like up here at the top, and then these tiles. Let's also add in the corner. Okay, the corner would go here, and then this is a top piece. Then we can go down here. Okay, so let's just get these corner pieces in as well. We'll just keep it kind of simple here for now. Then we need the side pieces, bottom piece, top piece, and we can kind of do the same thing over here. So let's go down. Okay, and then on up here, let's kind of curve around a little bit. Maybe we can make something a little more interesting. Okay, and then let's use this corner piece so that we can curve around here and continue going down. So I think we're going to need this one. Okay, we're going to end up with some more sand over here. Now let's curve the grass around again. Okay, I'm going to make grass over here, and let's keep going with that. So grass, grass, grass. Okay, on the right side, we'll go back down with some dirt. Go along the bottom. Grab this piece. Well, let's go one more with that, actually. And then let's go up this side. Curve it around again. And then finish up with those. And then this piece, of course, we're just going to change that back into this tile here. The important thing when you're laying down your tiles is just to look at it visually and see that everything matches up correctly, and that you get the transition right between two different two different types of terrain. So another thing we're going to want to make our grass look less boring here is to differentiate it a bit so that every grass tile is not just a simple green tile. And we can use these variation tiles over here to do that. So you can see these tiles will fit inside of the grass anywhere, but because they have some little decals inside of it, if we start putting them down like this, it's going to change up our grass and make it generally more interesting. So I would take a few of each of these and kind of put them around our scene and just make it a little bit more varied than it otherwise would be by default. So now if we look out a little bit, it makes it a bit more interesting. So I think that in the case of these little dirt plotches, these are meant to layer on top of the dirt ground tile here. So in this case, what you would actually need is a different layer for your tile map. So let's go up here to the grid and the scene hierarchy, right click and create another tile map. So let's call it rectangular, and I will call this ground top. So now if we click on ground top and we go and start drawing with the same tile palette onto this layer, you'll see that when we kind of pop that in, it's going to create the tile here, but it's layered against the background. So we end up creating kind of a combination tile in a sense. So let's just add a few of these spotches to various places. That might actually be enough already. Okay, and now if we kind of zoom out, deselect everything, we can see that adds a little bit more detail to our areas. If we wanted, we could even take these same things and kind of maybe pop them into the grass layered on top of it. Kind of more of a artistic decision at that point. So this ground top layer, we are going to want to make it above the base tile map, which I'm going to rename to ground right now. But we don't want it to be above the player. So if we put a decal right there on ground top, we don't want the player to render on top of that. So once again, I'm going to take ground top. I'm going to give it a value of, let's say, -3 in the sorting layer, so that if we put anything like right here, that the player is going to render on top of this ground spot. Okay, now let's create another layer so that we can add some fence into our scene. So I'm going to go to the grid, right click, do 2D tile map, rectangular, and I will call this collision objects, I guess. Let's go to the inspector and let's add a tile map collider here. So tile map collider 2D. So what this will do is automatically generate collision shapes around any of the tiles placed on this map. So I'm not actually 100% sure for the fences, whether we want that to be above or below the player. Let's go ahead and change the tile palette, and let's take some fence tiles and just add them into the scene. So I'm going to grab these three all at once by left click, holding, and dragging across to get these three tiles and place them on the collision objects layer. We can also add in a random stumpy post into there. And then I guess I will take the bottom left-hand corner and let's add another fence here as well. So this first piece is going to kind of face upwards. So I'll take these other pieces and go to the right, and this piece to extend that one that faces up as well, so that we have a corner fence. And let's cap it off with those end pieces, like so. Okay, the next thing we want to be able to do is to make it so that when we actually hit play on our game, that our player can move. So now let's add in the new Unity InputSystem package. Let's go to Window and Unity, and then go down to Package Manager. Inside of here, we're going to want to go to Packages and Project, and then change it to Unity Registry. And I'm going to type in input here. So we want the InputSystem and install it to the game. So the new InputSystem replaces the old default one. So if you're okay with doing that, just go ahead and hit yes. It disables it so you can always go back. The idea is that the code between default Unity and the InputSystem is going to look different. So once you start writing for one, you would have to adjust the code for it to work for the other. So if we go to player here, we can now add a component to the player, which is going to be, let's see, input, and then player input. So first off, let's take this gizmo and shrink it way down. So I think you click over here for that, and let's change the 3D icon size to be something way smaller than that. You can also see this plus sign to the component we just added. Because I added it onto the instanced game object, not the original prefab, it doesn't exist on the prefab. So if I click on the prefab in our inspector, you can see it does not have that component. But once you've added it to one, you can apply it to the prefab as well by clicking on these three dots on the right, doing added component, and then doing apply to prefab player. That also works if you change a setting like the scale and you want it to apply to the prefab as well. You can just right click on it usually. Let's mess with the scale, and then right click and you do apply to prefab. So I'm going to change that back to 1. Okay, so our player has this player input component, which is how the player game object is going to receive the input events such as keyboard, controller, whatever have you, for controlling the character. But in order for things to happen for the game character, we have to create a bunch of actions that will take that keyboard input and churn it into something that actually happens on the player. So you can do that by clicking on this Create Actions button. So let's do that. So we're going to have this Import Actions asset. So I'll call it something practical, player import actions. And I'm going to actually save this in the characters folder. So I'm going to click down here to expand the folders. Let's do characters and then player, and we'll just save it straight into here. So now it's going to pop open the asset, and you can see it has 3 default actions. Move, which has multiple types of input that it can work with. So if you plugged in a gamepad, like an Xbox controller, you'd be able to use the left stick to move around, or a WASD on the keyboard. So for right now, we're not really going to be messing with this, but just know that this is how you take the input on your keyboard and you churn it into actions with these key bindings. So let's close that out. The behavior I'm going to use is send messages by default, which means that in order for the script to do something, we need to implement these functions down below. So you can see on move here, on look, on fire. So we just need to make on move in order to make our character move. So let's add a new component. This is going to be our custom script. So add component, going to type in the name that we want to give the script here. So I like to go with player controller. And then you click on the new script link and we'll create and add this. So this will be a new C# script and you can open it up either in Visual Studio, or I like to use Visual Studio Code since it's a more lightweight editor. If you need to select which editor you want to use for editing your code, go up to Unity, Preferences, and then in this window, let's see, General. Okay, and then in the Preferences menu, you go down to External Tools, External Script Editor. You select from whichever one you want to use here. I'm using Visual Studio Code. So down here at the bottom, the plus icon implies that the prefab doesn't have this yet. So I'm going to click over here, add component, apply to prefab. Now I'm going to click on the 3 dots and then choose edit script. So now our project's going to be opened up in our editor of choice. It might look a little different if you're using a different editor, of course. And now we're going to start coding out our character. So the purpose of this script is going to be to take the import and handle movement for the player character. So we need to implement that void onMove function. So we're going to need to respond to this onMove message in code. So we do that by adding in a onMove function. So let's do void onMove. And so this is going to receive an argument from the message, which is going to be the XY direction that our player is trying to move when he presses the keys down or the left stick. So we get that as a input value. And I could call this movement value if I want here. Okay. And what I'm going to do is I'm just going to take the import value and I'm going to store it to a variable so that when we are doing our physics updates, we can actually move the player according to the direction that the player is trying to move by pressing down the keys. So let's create a vector2 up here. Vector2 has 2 float variables stored in it. In this case, it's going to be one for X, left and right, and one for Y, up and down. So the vector2, I'll call it movement input. Then in this onMove, we want to take the movement input and we want to set it to the value that we're going to get back from the input value. So you do that by doing movement value dot get, and we're getting a vector2. So get vector2, and then we're going to store that into movement input. So when we have this movement input, we're going to want to multiply it by a speed and time of sorts in order to figure out how fast our character is moving and in what direction. And so we're not going to be calculating that in update, which is called once per frame, but we're going to be doing it using fixed update, which is called a certain number of times per second and is recommended when you're doing anything that concerns physics. So down here, I'm going to type in fixed update, autocomplete that, so private void fixed update. And actually for now, I'm just going to cut away this void update. We might not even need it. So for this character, there's not going to be any acceleration. He's either just going to be moving or he's not going to be moving. So if there's no input, we're just going to idle. So we don't even need to try to move. You don't need to do any ray casts to check for calculations or anything like that. So I'm just going to do if movement input does not equal vector2.0. Then we'll try to actually do something here. So if the player is trying to move, then we're going to have to do a raycast check in order to see if the player can move in a certain direction. So if the player is trying to move, then we're going to need to check for collisions. But I actually haven't added the rigid body component onto the player so that it can interact with other physics objects in the game world. So let's go back to Unity for a second here. Okay, scripts compile. And I'm going to go into the prefab and the hierarchy. So where's this player over here? Click in here. Okay, so now we're editing the prefab and therefore every object in the game that is based on this. Let's add component and I'm going to do rigid body to D. So we want the body type to be kinematic. If you want to use forces to move the character, then you use dynamic. But if you want to move the character in a more classical 2D way where you would say move speed times direction equals how far it moves, then you want kinematics. So in many cases for these kind of games, you would use kinematic bodies. That's what we're going to be using here. Okay, so we have the rigid body. We're also going to need a collision shape. We might as well add that in now. So I'm going to collapse the rigid body properties and let's add another component. I'll do box collider 2D. Okay, so this will be the shape of our physics object. Let's edit the collider and we can see it is way too big. We want it to kind of match our sprite better. So I'm going to shrink it to basically where the character's feet are at. We'll just make it a little tiny box. So the reason we want it to be down here is because that's where our character is standing, and that's going to make the most sense visually when our character is bumping into objects. If we made it up here, then the head would collide with things, but the head isn't where the player is standing. So we want to imagine where's the actual base of our character if we were thinking of it in terms of 3D, which is going to be the feet in this case. So let's finish editing the collider. There you can see the little green shape, and let's go into code. So now that we have these components added, we can find them in script and use them in our code. So for the rigid body, I'm going to do rigid body 2D up here. And I'll just call it RB. When the game starts, we want to get access to that rigid body. So I'm going to do RB equals get component rigid body 2D, parentheses. So get component is going to be looking for a type, and this is the type of the component. So when it finds a component that has that type, it's going to get that and store it into the rigid body. And that's basically how you access any components you want that are attached to the same game object. Okay, so before we do the raycasting, you might not get the error messages initially when something's wrong with your code. So if you're on Visual Studio Code, you're going to want the Unity tools, like Unity tools, debugger for Unity. And if you've grabbed all that stuff, you can go over to this debug tab and do generate C# assets for build and debug. And that way you'll be able to see some of the problems you might have here. So vector2.0 is actually lowercase. And in the case of the input value, we need to get reference to the namespace for that input system. So I'm going to do command period, and then I'm going to get using Unity Engine input system. So this is going to be needed up here at the top, using Unity input system. And that should clear up the error messages here. So now we can do a rb.cast. So for rigid body cast, there's many different overloads for this function. So I'm going to grab one of them and put it here, and then we will talk about it. So I went ahead and copy pasted the full call to this cast function using one of the overloads. So the parameters are as such. So you have the direction here, which is actually just going to be the movement input. So I will change that there, and that clears that one up. Then we have the movement filter, which is a list of settings, which will determine what this raycast can collide into, or what it will just simply ignore. And we'll add that up here at the top. Over here, we'll also have a list of collisions where we can store the results of this raycast. And then you need basically the length of the ray that you're casting, which is going to be based on the time between the frame, a offset value to basically go a little bit further than the amount of movement you're going to move, and this can help you avoid getting stuck in the wall. And then the movement speed. So the movement speed we'll declare up here as a public float variable. So let's call it move speed, and I am going to just set this to 1f by default. So one of the reasons we make it public is it'll actually appear in the Unity inspector, and so you can change the value inside of the Unity editor without touching your code. So the other things we're going to need here is a contact filter 2D, I believe, and we'll call this movement filter. Then we're going to need a private list of cast collisions. So this will be list of collision 2D. That's going to be called cast collisions. When our script starts, we will just initialize that as a new list, just like that. So this will just create an empty list. And whenever this raycast runs, it's going to replace all the stuff in the list with the collisions that it finds. And then we need a collision offset. So I will also make this a public variable in case we need to change it. So public float collision offset, and we will set it as 0.05 for right now. And we'll customize this as we find it's either raycasting too far to pick up on a collision or too short. But that should be okay for right. So we'll try this for right now, and we'll customize it later. And yeah, okay, it's not a list of collision 2Ds. It's actually a list of raycast hit 2D. So just change the type in the list to raycast hit 2D. And let's copy that over here to the new list being created. Okay, and that should clear up our issues there. Let's take a look at the Unity editor for a second. the scripts will compile. And now we have our movement filter, the layer mask where we're going to be colliding. I'm going to change that to, let's say, default layer for right now, but we can change that layer as we need to. Everything else, just going to leave that as the default. And we have our move speed and our collision offset. So to kind of explain what's going on with the raycast, if we want to move, let's say 50 pixels over here or so in a single frame, if we do a raycast, we can check to see if there is an object over here that would block the player's movement into that space. And then if there is a raycast hit, then we can choose to prevent our player from moving in there. Otherwise, if we were to just say, okay, move the player from here to here and don't check for any raycasts, then the character would just pass through everything and it wouldn't interact with the physics at all. So we use the raycast to check if a move is valid before we make the move. So in this case, if we do our cast in the direction where we're trying to move, the movement input direction, and we get a count of 0, then that means there's no collisions and the move should be valid. So we're going to go ahead and make the move. So to do that, we are going to take, let's see, rigidBody.position is one way to do it. Or let's do rigidBody.move position, actually. And so we'll take the position of the rigid body, and then we'll add this to the move speed times the time fixed delta time times the direction. So this will give us our magnitude of the vector, and then this is going to be the direction of it. So we want movement input times move speed times time dot fixed delta time. So I don't think I really mentioned much about the fixed delta time. So when you have a Unity game and you have fixed update, your game will have a set setting where every second there will be a fixed number of frames where physics updates take place. So this should be consistent between every physics update frame and fixed update. And therefore, this fixed delta time should stay consistent, basically. And we take the amount of time between frames, multiply that by the movement speed to get how far it should move. Now, it's important to have the fixed delta time if there was a difference between the frames for any reason, because if your frames are playing faster at one point in time than at another point in time, then you would want to move the player less between the frames because the time between the frames is less. Basically, this ensures that the movement is consistent regardless of how long it's actually taking the time between frames to update. And then we just multiply that by the movement, and this gives us the total amount and direction to add to the player's or the rigid body's current position. But this move position, we only want to actually run that if the count is 0. So let's make that the condition here. Otherwise, if there is a collision, we're just not going to allow the player to move, at least for right now. So let's go back over to Unity. Okay, and let's move around our player. So left, right, up, down. The import is coming in. We're receiving the on move, and we are actually using it right. So let's see if the physics here works at all. So moving around there, doesn't look like it. So let's figure out why. So if we go to the grid in our scene, click on collision objects, do we have the Tilemap collider here? So the reason why these over here don't appear to be colliding, but then this stump over here, the player is colliding with just fine, I believe is simply because these are not on the right layer for the Tilemaps. So if I click up here and let's hide ground top, okay, we can see that this is actually part of ground top, not of collision objects. So we need to go to ground top. We need to do tile map. I'm going to use the eraser tool on these 3. And let's go to collision objects and then put these 3 back in wherever we want them. And when they're added here, you can see that they now have a collision shape automatically generated around them, thanks to the Tilemap Collider 2D. Okay, and I think they were down here actually, so I'm going to move them. Let's go ahead and hit play. And let's see if we can collide there. So yes, we are colliding. It doesn't look perfect here because of the order in layer and also the position where we're casting from, which is going to be probably the center of our object, not where our box collider is. So let's hit play there. And you might notice that when you kind of need to go back into play mode, it may take a little bit of time in order to do that. So when you're editing your game, one trick you can do is to go up to Edit Project Settings. And then you go down to Editor, and if you scroll down here to the bottom, you can enable interplay mode options, of which is going to disable reloading the domain and reloading the scene. So when I'm just editing the game and I need to test really quick, I'll just have the reloading of the domain disabled here, but I'll check reload scene because generally the scenes reload very quickly anyway. So now if I click play mode, you'll see that switching into play to test the game again is almost instantaneous. The drawback of doing this is that by disabling the reloading of the scene and the reloading of the domain, it's possible that some things may not perform exactly as they do in the actual published build version of your game. So there may be cases where you do not want to enable play mode settings, but it does speed up the process when you just need to jump in and out like this. So another thing that I want to adjust here is that when we go over here to the fence, that the fence is rendering on top of the player. So once again, we should probably already know how to do that. Let's exit play mode, go to collision objects, and I am going to take the order and layer, and let's make this -2 here. As long as it's lower than the player, that should be okay. Go to play mode, and then walk over to the fence, and that is what we're looking for, the player sprite to render on top of the fence. So when we're behind the fence, this works okay because our player is not walking below the fence. Now when we go up on top of the fence and we try to go down, we can see that there's quite a lot of distance here between where the player is and where our collisions start happening when we're trying to go down. So to fix that, we can kind of shrink that collision offset. I'm going to try making that 0.02. Let's go into play mode and test that again. And now we can see that the spot where our collisions happen with the fence is a lot closer to where the fence actually is. So that should work okay for right now. Another thing we might want to be able to do is to make it so that when we approach a object diagonally, kind of like this, that rather than completely stopping the movement, we'd still be able to slide in one direction. So here we could probably move up. And if I let go of the left key, you can see I can walk up. But if you have two keys pressed down at once, then you're unable to slide around the object. So a pretty easy fix for that is going to be to test only on the X direction and only on the Y direction for movement. And then if you can do a X direction movement without collisions, then you just move in the X direction, and likewise with the Y direction. But only after checking for the initial movement input. And so checking for the X and Y separately would happen if this base movement input failed. So what we can do, since we're going to run this 3 times, is just to cut this out into its own function. So this function, I'll make it private. I'll have it return a Boolean, which is whether it was successful in moving or not, or if it ran into a collision. And I can call it try move, and this is going to be taking a vector2, which is the direction which we're going to try to move in this function. So I'll paste the code in here, and let's adjust the tabs. So rather than using movement input for the direction, I'm going to be using this direction. So let's change that there, and I'll change that down here as well. Since if we check a direction for collisions, we want to use that same direction for the direction we're going to move. And of course, we need to return true or false for this to work. So if the movement occurred, then we're going to return true. Otherwise, we're going to return false. So we can run the try move on the movement input direction, and then that will function just like it did before. Okay, so let's save the results of that. So bool success equals try move. So if it wasn't successful in moving in both directions, let's see if it can move in one direction. So success equals try move, and we'll do movement input dot x and then 0 for y. Okay, and we need to actually create that as a vector2. So new vector2, and we need to wrap that in a vector. So vector2 movement input dot x and then 0 for the y. So success equals try move vector2. Okay, got to put the new keyword there. Okay, so that's going to try it with the x direction only. And I guess we'll check if still not successful, then we'll do try move again. This time, new vector2, 0 for x, and then movement input dot y for the y direction. So it's going to do a normal movement, and if that fails, then we're going to try to move only on the x-axis. If that fails, we're going to try to move only on the y-axis. And this will let us slide along collision objects that we otherwise couldn't move directly into, but we might be able to move around. So if we hit play now, And let's go at this object with 2 directions. I'm going to press A and W down. You can see we kind of slide right there along the left and come out the other side. So this just makes the movement a lot smoother and probably what you're actually looking for. So next, let's set up animations for our character. I am going to jump into the prefab for our player. I'm going to add a component here, which is going to be an animator component. And this is going to need an animator controller. So in the characters player folder, I'm going to right click here and create a animator controller for our player. So we'll call this AC_player, animator controller player. And then we take this and we put it into the controller for the animator component. Now we can open up the animator window. So go to Window, Animation, Animation. I think we also are going to need the animator window. Okay, so the animation window is going to be where we create the clips. I will actually put this on the right next to the inspector, and then we'll do Window, Animation, Animator. So this will basically be where you put in the animation logic for switching between the different animations that your character can play. And in the animation window is where you set up the individual clips, the sequence of sprites or images that you want to play for the character running or walking or swinging a sword or whatever. So in the player folder, I'm going to right click, create a new folder, and this is going to be for animations, just so it's a little more organized. Then where it says to begin animating player, create an animation clip, click on create, and let's go into animations here. And I'm going to call this player_idle and save. You can see in the animator window, the animation pops in here immediately, and we might actually be deleting this in favor of using a blend tree later on, but for now, it can be just left there. So let's go to the scene view, click on the player. Let's set up this idle animation. So we need to grab the frames for the player idling. In some cases, that is just one frame. Let's open up the sprite sheet. Let's look at this, and let's see what we've got here. So I'm not certain, but I think these first 5 frames may be a idle animation, so we'll try that. And then after that, we have the run animation from player 5 to player 12, and then swinging a sword is 13, 14, 15. Then 16, 17, 18 is the character's death animation. So let's set up those animation clips. I'm going to left click on this first frame, hold shift down, and then click on the last frame, which is player 4. I'm going to drag these into the animation window. This will create the player property sprite animated. And if we zoom in, middle mouse wheel, we can see all of these frames. I definitely think that it's not going to be playing 60 frames per second. So I'm going to change the samples here, and let's set it to something like 10. That's going to make it so the timing between our frames is spaced out a lot more. Let's hit play. Okay, and then we have our player idle animation. And actually, I think that is how it is supposed to look. That looks like the right speed. So let's do the same thing with player walk and player attack. So click up here, create a new clip, player walk. Now we need to grab the other frames. So player 5 here to, I think we're looking at player 11. So I'm going to drag this in here, set the samples to 10 to slow down the animation, hit play. And there's our walk cycle. So next, create a new clip, player attack. Grab the attack frames. So that is player 12 to, I think, player 14. And let's drag that in there. Samples to 10, hit play. There's our attack animation. Okay, lastly, we'll do player death, I suppose. So let's do player death for the name of the animation. Grab the last 3 frames here, put it in there, and then sample set to 10, and then play. So that's the death animation. Might actually be playing a little too fast, but basically, seems like we got it right the first time. Okay, so if we switch over to the animated window, we're going to see all of these animations pop in here. And we need to set up the logic for which animation we're going to be playing. So we can do player idle to player walk first, which will be pretty straightforward. It's going to be, is the player moving? If the player is moving, then we're walking. So in order for our animation to switch between player idle and player walk, we're going to need to set up a parameter in our animator controller so that it knows to switch between those 2 animations. So in the animator, switch from layers over here to parameters. and then click on the plus button and choose Boolean. So the Boolean, I'll call it is moving. And then this is moving parameter will be set in code on a script attached to the player. So let's make the transition from player idle to player walk. Right click, make transition, and then click on player walk, and then right click on player walk, make the transition back to player idle. So if we click on this transition, the little arrow here, you can see that it can handle a condition in order to allow automatic switching between player idle and player walk. So click on the plus. Is moving is set to true, which is what we want. And then for the one up here, we want to click the plus. Is moving, but we want to change this to false. So when the player stops moving, we start idling. Now, the other thing for these kind of animations where we want them to stop immediately at any point in time is that you're going to want to turn off has exit time, and you're going to want to make the transition duration 0. This will make it so that when you switch from player idle to player walk, or vice versa, that it happens immediately, and that will look correct. So also click on the top transition here and do the same thing. Uncheck has exit time, and then 0 for the transition duration. Okay, now let's go back to scene view. We should open up our player controller script one more time so we can actually set that is moving variable on the animator. So let's open it up, edit script. Okay, to do that, we have to get reference to the animator component. So down here, I'm going to do animator. And just like with the rigid body, I would do animator equals get component, animator, parentheses, and now we have our animator component while the script's running. So to set that parameter, I guess what we'll do is if we're trying to move here, we'll take the success and set that to the animator's value. So animator.set boolean, and it's going to take the string name, which we set to, and we can always go double check. So in the animator, it's is moving, needs to be the same name. So is moving, and we'll set that to success. Otherwise, if we're outside of here, the player isn't moving at all or trying to move. So we'll just do animator.set boolean is moving to false. And then that should work for right now. So let's go back to our game view, hit play, and let's try walking around. So we can see the animation plays when we're moving, and when we're idling, it just does the idle animation. The only thing here is that if we're trying to walk to the left, it doesn't switch to the left view. Now, depending on your character, there would be a few ways of doing that. One way would be to have a blend tree for the 2 or 4 different directions your character can face. But an even easier way is just to flip the sprite if you need it to face left. So you can flip X as a property you can just set when the character is trying to move to the left. So what we can do here whenever we try to move on fixed update is that we'll set the direction of sprite to movement direction. Okay, so to do that, we need to get access to the sprite renderer. You can see how we have to grab a lot of components over time. So our sprite renderer here, I will just put up here, sprite renderer, sprite render. We'll get this when the script starts. Sprite renderer equals get component sprite render. And now that we have that, we can just set the flip direction on it. And we'll set this to true under one condition. And in another case, we'll set this to false. So the condition where we would want to set it to true is when the X direction is negative, because that's when the character is trying to move to the left. So if movement input is less than 0, then we'll set that here. Otherwise, else if the movement input is greater than 0, then we'll do flip X equals false. So in the case where it is set exactly equal to 0, we don't want to change the flipping because we haven't actually put any input onto our character, so there's no reason it should flip for one side or the other. The other thing is we have to change this to movement input.x. It's a 2D vector, so we're only checking one component, the x value of that vector. So in some conditions, when it's trying to move left, we'll flip the direction to the left. Otherwise, we'll flip it to the right. So this will actually make it so that with one animation, we can have it handle the other direction of the animation. So if we need to swing to the left, we can do that, or swing to the right, we can do that as well. So let's hit play and see if that's working. I'll hit left. Okay, and our character's facing left. Hit right, our character's facing right. And we can basically move around the screen. And at least as far as moving around, this is working pretty good so far. So although our movement is basically working for the most part, one issue I find when we run up here is that the success of a movement is being set to true even if we don't actually move. So what's happening right here is I'm pressing W, walking into the fence. That fails because we have a collision. So then we check sideways even though there's no A or D movement. And when we do that, it's going to have a success, because it's going to be trying to move with a vector of 0, 0, and there's nothing over here to the side. So in order to fix that in our code, what we got to do before we try these extra moves that are just on the x-axis and just on the y-axis, we should only attempt it if there's actually a movement x value here. So I'm going to put and as an extra condition, and we're going to do movement import.x is greater than 0. Going to pull this out of here, put this down here as an extra line. So if we still haven't had a success, whether or not this actually ran, we're going to only check this if movement.y is greater than 0, 2. So now these try moves shouldn't run and shouldn't have a success unless there's an actual movement input. Another alternative we could do, and I might actually like that more, is that if we come in here and the direction is 0, 0, then we just return false. So if direction is equal to vector2.0, else we return false, because we can't move if there's no direction to move in. So these two things will achieve basically the same thing. This might actually be the better way to implement it though. So let's go back to the game and make sure that when we actually run up here, that it's going to stop showing the character is moving, because we're not actually moving. Ah, okay, I made a mistake here. It's supposed to be not equals to 0, not equals to 0. So now we go back in here, we're moving around, and let's see, when we get up to the fence, we stop moving because it's not going to try to do a movement if there's no direction to move in. So these AD movements of 0, that's not happening. Likewise, we go to the side and we just run at the fence. It's not going to be checking to see if we move up here because we're not trying to move in that direction. So now our movement looks a lot better overall. Another thing we're probably wanting right about now would be a follow camera. So we can add that to our project pretty easily using Cinemachine. So let's go up to Window, Package Manager, and grab that package. In the search, I'm going to put Cine, or C-I-N-E, get the Cinemachine, and install this. So now to set up Cinemachine so that we can have a follow camera on our player, let's go up to Game Object, go down to Cinemachine, and then we need to choose 2D camera here. So this will create another object inside of our scene, our CM Virtual Cam 1. Note that the main camera now has some extra stuff added, like a Cinemachine brain. So we click on our CM VCam 1, and we need to give it a target to follow. So let's select our player from the list. So just click on that little circle and then choose the player transform. Now if we go ahead and hit play, you'll see that our Cinemachine is helping the normal camera to follow our player around the screen with a little bit of lag. As you can see, this is like the center point for the camera, and it doesn't follow the player immediately. It takes a second for it to catch up. So one thing you might notice when you're using the Cinemachine is that your pixels might look a little choppy again. So what you can do on your virtual camera is to add an extension to it. So I'm going to add the Pixel Perfect extension. So now when we go back into the game and hit play and we walk around, it should look correct for how our character animates and walks around the screen. There shouldn't be any jarringness or anything like that. So yeah, that's looking better. So next, let's jump into the animator for the player. And then let's create a transition to player attack. And then for player attack to go back to player idle. Okay, so for the player idle going to player attack, we want that to happen on a trigger. So this will be an event that happens and that will send us into the player attack state. So I'm going to add a parameter here, and this is going to be a trigger. And we can call it, let's say, sword attack, I suppose, since it's very possible our character might have multiple types of attacks later on. That might make the most sense for a name there. So now we need a condition where we're going to set this sword attack and transition into the player attack. So let's add that condition here, idle to attack, and we'll do the sword attack trigger. So you can see here there's no true or false value. A trigger is going to get consumed when we move into the attack state. So if we click on our character and we open up the player input, we can see that we have the messages which we can respond to, like on move, on look, on fire. So if we're just using the default player actions, then we can see fire is already set up. In this case, that is going to be left button on the mouse, right trigger on the gamepad, and so on. And we could use this for an attack. You could also, of course, add in your own custom actions, but we'll just keep it really simple for this tutorial. So fire here, we're going to respond to on fire in code. So when we jump into code, we can come down here to the bottom, and we're going to respond to the on fire message. So this is going to happen when our left mouse button is pressed, and we're just going to need to put ourselves in the attack state. But before that, let's just test that this is actually working. So I'm going to print fire pressed, and now let's go back over to Unity and test that that is actually working for us. So if I click play and we press the left mouse button down, you can see fire pressed. Okay, so now we need to take the animator and set our parameter onto it. So animator dot set, let's see, trigger. And we're going to do the sword attack trigger. So let's go into play mode, hit play, and we can see our attack is actually playing there. It seems to double play and not go back to the idle state so quickly. So let's see what's going on there. So in the transition, first off, we're going to want 0 for the transition duration, and I think also 0 for the transition duration at the end there as well. But I believe for going back, we want the exit time to possibly be 1 here, as in when the animation is completely finished. So if we click play, we go back into play mode, we left click press, we get our sword attack animation, and we go back to idle state after that. So when our player is walking, we can't make that transition into the player attack state because there's no transition here. So let's set up the same transition between player walk and player attack with the same condition. So sword attack is triggered, 0 for the transition duration, and turn off has exit time as well. Okay, in this one, player idle to player attack should also have has exit time turned off. So we hit play. Let's go back into it. Okay, and now our transition to player attack, whether we're walking or just idling around, is immediate. When our character is attacking, though, we don't want to be able to move around. So let's actually turn off movement during that case. So let's create 2 public functions, one to lock movement, so public void lock movement, and then another one to unlock movement. So up here at the top, we'll have a Boolean. So let's say Boolean can move, and that's going to be set to true by default. And lock movement is going to make can move equals false. Unlock movement is going to make can move equals true. So if can move is set to false, then we're not going to be able to move. So we will basically turn off all of this code temporarily. So if can move, then we will allow all of this to occur. Otherwise, we can't. So when can move is off, we won't be able to move our character around. It'll only be able to play the sword attack animation. Obviously, when we unlock the movement, then this will start resuming again. So a pretty convenient way to call those functions is going to be in the animation clip for that. So let's click on player here. Let's go to player attack. So on frame 0 for this animation, I'm going to click, let's see, over here, add an event. Double click on the event. And let's temporarily move the animation down here so that we can also see the inspector. So we select the event, and the event we're going to do is going to be lock movement. So now we come to the end over here, and let's unlock the movement. So add an event, select the function unlock movement from the script. So now if we hit play, I'm going to be moving around. Let's left click. Oh, and look at that. While we're playing the sword attack animation, we can't move, which is probably a lot more what you would expect. Okay, so now when our character is swinging, we're going to want there to be a hitbox so that we can hit enemies and deal damage to them. And this hitbox will only be active while the attack is actually going on, of course. So let's dive into our player object, and we could add another box collider to the player, but I think it would be better to create a child game object. So let's right click on this and create a new empty, and we can call it sword hitbox. I'm going to add a component here. We're going to call it a box collider. Let's shrink the collider down to about 0.18 and 0.2 for the Y size. Okay, and now we can change the position of the transform here. So let's move this over here to the side. Let's put the player in his attacks animation by switching to that animation over here. And just adjust the position of this sword attack until it kind of makes more sense. So we could actually make it a little bit taller, 0.25. Okay, I think that's quite generous there. We'll go with that. And what we can do, when the player's facing right, it'll work just fine like this. We'll enable the hitbox. And when the player's facing left, we will just reverse the position to be -11. And when the player's facing left, we'll swap the position of this hitbox to be over here on the left so that the sword is actually swinging to the left. So rather than adding the attack directly to the player on a player script, it might make sense to actually create another script in here. And then the player can tell the sword hitbox script when to be active and what position to be. But this will determine the damage that the player does to an enemy like the slime. So let's try creating a new script. Let's just call it sword attack. Yeah, sure. Sword attack, new script, create and add. Okay, so let's go ahead and edit our script. So in this script, let's set up a couple functions for when we're going to attack to the right and attack to the left. So let's do public void attack right. And then let's do public void attack left. And we'll want to stop the attack. So public void stop attack. So this box collider, which we should make a trigger, because it's not going to partake in any physics, we will set this to active when the sword attack is actually triggered. So inside of here, let's get that collider. So I'll say collider 2D, I'll say sword, and we'll call it sword collider. On start, we'll get reference to that sword collider. So sword collider equals get component collider 2D. Now note that I'm doing collider 2D, not box collider, because we may want different shapes that our attack could collide with. We may not necessarily use a box collider in the end. So this keeps it a little bit more vague. So public void attack right. The first thing we're going to do is enable the collider. Okay, forgot the parentheses there. So sword collider dot enabled equals true. And it should be here as well. Sword collider enabled equals true. But down here, we're going to disable that collider. Sword collider dot enabled equals false. Also, something we can get also so that we know the position where we expect it to be offset from the player when we're running the game. Let's get this value and set it to a variable when the game starts. So this will be our runtime initial so this will be our runtime. So this will be the base value, which we use to set the new position depending on what direction we're attacking from. So edit position. So let's edit the script, and I'm going to get a vector2. Let's call it attack offset. So the attack offset is going to be equal to the transform dot position when the script starts. So we store this in here because we might change that transform position when we're doing an attack right and an attack left. So when we do an attack right, we're going to take the transform position and set that equal to the normal attack offset. And we could actually call this right attack offset. I think that's more clear because that's what we're going to be using as our default value. And then for the left attack, we're going to take the transformed up position and we're going to set it to a new vector, which is going to reverse the x value of the attack. So right attack offset dot x times -1, and then we're going to take the right attack offset dot y, and we're just going to use that value. So the only difference is that when we attack left, we are reversing the offset from the player to be from the right side to the left side. So now we need a way for the player controller to tell the sword attack whether it should be attacking from the right or attacking from the left. I think a good way to do that is going to be to set up a enum variable that the player controller can control. So let's go up here and create a public enum, which is basically a way of adding a human readable word to an integer value, and then we can use it in a switch statement. So public enum, and I will call it attack direction. Okay, and we'll have two values here, left and right. So now we'll need a attack direction variable based on that enum that the player controller can set. And we will set that to be, and I'll just call it lowercase attack direction. So the attack right, we're not going to be calling these in the animator. We'll just call a simple attack function. So I'm going to make these private actually. Stop attack can still be public. So our actual attack that we can visibly see, public void attack, we'll call it, or you could call it swing or whatever. We'll do a switch statement, and that switch state. So when we go into the attack function, we'll do a switch on what attack direction we're supposed to use. So if the attack direction case is attack direction dot left, if I'm writing this right, then we do attack left. Otherwise, attack direction dot right as the other case, we do attack right. And by setting it up with the enum variable, we could just add extra possibilities up here, like attack up or attack down, and we'd just be able to handle the cases pretty simple down here. Let me go ahead and correct this error. Could be because I don't have the break. Yep, okay, there we go. So you gotta add break to the end of your cases to fix those errors. Okay, so we'll call attack from the animation and stop attack from the animation. But in player controller, when we set the flip direction of our player, let's also get access to the sword attack. So I'll just declare public sword attack up here. I guess sword attack. Let's go into Unity now. And on our player prefab, we can just drag and drop the sword hitbox for the sword attack into here. Okay, now it's going to be able to be referenced inside of that script. So back in here, when we flip to X, we're going to set the attack direction of the sword attack to be equal to sword attack direction dot left. And over here, we'll do sword attack direction equals sword attack direction dot right. And this one should be capital because we're talking about the enum here. This is capital as well. Okay. So basically, oh, and I actually got these backwards. No. Okay, so basically whenever we flip the sprite renderer direction, we're also setting the attack direction for the sword attack and telling that script to basically change that. So now whenever we call the attack, it's going to be facing the right direction by default, or it should be anyway. So actually, I think I have a slightly better way to do this. So we have our lock movement function and we have the unlock movement function. Let's expand that a bit. So when we lock movement, instead of just locking the movement, let's make a player void sword attack function. And so what we'll do is we'll lock the movement. Okay, so down here, when we call the sword attack, we can just do sword attack and then do attack left, or sword attack dot attack right. And we'll do that based on the direction of our sprite flip here. So we won't use enums actually, at least for right now. Let's go back in here. We'll get rid of this attack and let's do public attack right, public attack left. Get rid of the enum. Okay, and now down in here, we'll just check if the sprite render dot flip x equals true, then we're going to attack left. Otherwise, we're going to attack right. So sorry for any confusion there. The enums option, you know, it would work too, but I think this is just a little bit more straightforward now. So I think that's what we're going to go with. So as long as your sword attack script is set here, we'll be able to call the attack functions on that. And in order to get this sword attack to trigger, all we need to do instead of calling lock movement on the animator is sword attack. So in Unity, let's go to player attack, and this event, we're going to change it to be sword attack. And to make sure that's working, let's go in here and we'll do a print attack right and a print attack left. Hit play, and let's go to the console. So let's see if this is working. Attack left, attack right. So the last thing we're going to need to do for these animations is to add an enemy and then to try to deal damage to it. So for our sword hitbox, we have a box collider, and it's being set on is trigger mode. So that means that there's going to be a message we can respond to, which is on trigger enter 2D. And if this is the case, we want to see if the other collider, the thing that this box collider is colliding with, is a enemy. And if it is, then we're going to try to deal damage to it. So if other, let's say other.tag equals enemy, then we'll try to deal damage to the enemy. So let's quickly set up a slime and make it so that we can deal some damage to it. So I'm going to right click in the hierarchy, create a new empty object. We will call it slime. I'm going to tag it immediately as enemy. So let's add a new tag. I'll add a custom tag here, enemy. Okay. If we click on the slime, we should be able to set that there. Okay. So we're classifying what this object is. Let's add a sprite render so that we can see what it looks like. And let's go grab the characters, the slime. Let's see. Let's put slime frame 0 into here. Okay, there's our little slime. Let's also turn this into a prefab object. So in characters, I'm going to create a new folder. We'll call it slime. And let's drag the slime into there. So the slime is going to need a collider, probably a rigid body too. So the slime is going to need a collider and a rigid body. So let's do rigid body. And so let's go into the prefab for the slime. I'm going to double click into it. Let's give it a rigid body 2D. And that is going to be of type kinematic. If we're going to script its movement, it's going to move like the player in a kinematic form, not affected by forces necessarily, unless we code that in for the kinematic movement. And then let's add in a, let's say box collider. Or, you know what? A capsule collider might make more sense. Sure, let's do a capsule collider because it fits the shape. And let's resize it to be roughly the size of our slime character there. Okay, so let's add a new script. We'll call it the enemy script. So this will just be a really basic enemy. We might build other scripts that build on top of this. So this will just be a really basic implementation of an enemy, and I guess the idea will be that this script could be attached to other enemies as well. We'd just be changing out different animations and art for the characters. So let's edit the script. So I'll keep this really simple. Let's do public void take damage, and let's give it a float and amount, or let's call it float damage. And then let's give the enemy a health value. So public float health equals, let's just say 1. And we'll do health minus equals damage. You know what? It would actually be better to set this as a property. So let's do public float health as a property, wrap it in parentheses, and let's do a set function. So health equals value, and if health is less than or equal to 0, then we'll run some kind of defeated function. Okay, let's put that down here. So public void defeated. So just to keep it really simple down here, I think what we'll just do is destroy the game object. So we're just removing the character from the scene, basically, when the health drops to 0. And we can also do a get, which will return the health value. So here we do health minus equals damage. And since we're setting it as a property, whenever we call that setter function here, we're already checking to see if we should be defeated. So anything that would affect the health, as long as we just set the value here from here, we can already have those checks included. So that can work a little better. So now we just need to deal damage to the enemy. So let's go back to the sword attack. If our character is tagged with an enemy, then it should probably be of the type enemy. So we'll see if we can get the enemy component on that other collider. So let's do enemy equals other.get component. And we're looking for the enemy script. And then if we can find that, if enemy does not equal null, then enemy.take damage. You know what? Actually, let's just do enemy.health minus equals, and let's do damage. And okay, let's make that damage variable up here at the top. So public float damage. Let's put it at 3. That's a super strong sword. Okay, so I actually don't need this take damage function at all. We could just affect the health directly. So the health is going to be minus equal the damage, and if the health drops below 0, then the character will be defeated. So our character has a collider, it has a rigid body. So that might actually just be all we need. We just need to go up to it, swing the sword, and it might remove it from the scene. So let's go ahead and use our sword power. Okay, so let's hit play and go take a look at this. So one issue here, I don't think we actually want the character to be able to get stuck on the body of this character. So let's take the capsule collider and set it to is trigger only. So I'm going to hit play now. Now we can walk straight through it, and clearly the slime was destroyed there, but the problem is that our box collider should not be enabled yet. So on the sword hit box, let's turn that box collider off and make sure that it's off by default on the player prefab as well. So we will turn that on when we attack. So likewise, when we unlock the movement, we're also going to want to stop. So likewise, when we unlock the movement on the player controller when our attack's done, we're also going to want to tell the sword attack to disable the collider again. So let's change this to be public void stop attack, or we could call it actually end sword attack. Okay, and we'll unlock the movement here, and we'll also tell the sword attack to stop its attack. So stop attack function. Now when we come back into the player, for the attack animation, we come here to the end. Let's change unlock movement and let's change it to end sword attack. So now we have the start of our sword attack, the end of our sword attack, but by default the sword hitbox is disabled. So let's click play. We can walk straight through our enemy. There's no attacking going on. But if I left click, well, it should have enabled, but did it? I guess. Okay, and I think I know why that is. So the collider 2D, we don't need to define it as a box collider necessarily, but if we're just getting the component collider 2D, it's not going to find that specific component. So we need to get rid of this, and what we'll do is we actually define which collider 2D in the inspector. So change collider 2D to public collider 2D and get rid of setting it in the start function. So now we go back into the inspector, and let's take this box collider 2D and set it there for the sword collider. Okay, so when we go back into play mode, we can take a look at the sword hitbox and see that when we left click, it does enable and disable, which is what we're looking for. So one bug I think I found is that whenever we left click and we set the new position for the transform, it's actually setting the global position, because you can see these numbers are all kinds of screwy. So what we actually need to do when we set the position is to set it to the local position. So transform dot local position is going to be relative to the parent. So let's set that over there as well. Set it, and now when we actually attack, we should be seeing 0.11 or negative 0.11. So let's hit play and go around. Yep, okay, now it's working. So let's swing and... Okay, well that guy got hit. So now that one's also being hit, and okay, that one as well. Okay, so now the hitboxes seem to be basically working. So we swing, okay, his health gets set to -2, -2. And these print messages are just extra lines I added in to the on trigger enter. We can go ahead and remove those right now, as well as printing the value of the health whenever the health is set. Okay, so now we have a way of defeating the enemies. We can make the slimes a little bit more interesting by adding in animation to them. So let's add in a animator for the slime. Okay, and let's apply that to the prefab there. So right click, added component, apply to free. So click on the 3 dots, added component, apply to prefab, and let's jump into the slime prefab as well. That will make sure that all the changes are actually set here. So in our slime character folder, let's right click, create a animator controller, AC slime, and let's bring that into the animator for the slime prefab. So now we got to open up the animation window for the slime, and over here on the right, we can create a clip for it. So let's do slime idle into a new folder. Once again, we will call this animation for the slime, save it in there. And let's grab the frames from the character. So let's see, probably these first 5 frames again. So here I'm thinking this is probably the first 3 frames. Let's start with those, set the samples to 10 like before, and hit play. Okay, possibly 4 frames. I will try to add that 4th one in there. I think that's looking a little bit more correct. So I think that's our idle. If you want, you can create the, which might be up to slime 16 here. Let's add those frames, set it to 10. Let's loop this. Okay, there's our jumping animation. Let's create slime damage, which from 17 to, I think, 19. We want to add in those frames. Hit play. Do we need the frame 20 here? No, I don't think this one is there. And we'll add in slime defeated, which will be the last 5 frames, slime 20 to slime 24. At 10 samples per second, hit play. So there's the animation for that. So if we want to switch to the defeated death kind of animation, we could either set the health float value in the animator, and then when it drops below 0, we just play the animation, or we can have a trigger here whenever we are defeated. So let's create another function to finalize after that animation is done. I'll call it remove enemy for now. But when we're defeated, we're going to tell the animator to set a property. So let's get that animator component up here at the top, animator, and then we'll implement the start function. So animator equals get component animator. And then the animator will do set trigger. And let's call it defeated. So if we go back over to Unity now, let's open up the animator, but for the slime. So click on the slime. We have move, we have damage, we have defeated. For right now, I'm just going to create the link from idle to defeated because we're defeating them in one hit anyway. So let's do idle, make transition to defeated, and this will happen when our trigger parameter is set. So let's add the parameter over here on the left, and this is going to be defeated. Okay, click on the transition, go to the inspector. It should have no exit time from idle to defeated. So uncheck that, transition duration 0, and the condition is just defeated. So this should be a one-time deal. Now, when we play the slime defeated animation, we want to call the removal of the object at the end of that animation. So in the animation window, click on slime defeated, go to the final frame here and add an animation event. Click on the animation event, go to the inspector and find that remove enemy function and add it in there. So now if we go ahead and hit play, we're going to deal damage to the slime. Okay, at least in theory, it's going to deal damage to the slime. So then we play the animation, and after that, it's removed from the game. Now, let's see why the sword hitbox may not be actually... I'm going to assume that it's not big enough. So let's go into the player, and let's just make this sword hitbox a little bit bigger. I'm going to give it a vertical size of 0.3, pretty huge. And let's go back out to the game view, hit play, and test this. So we're going to attack. Okay, that hits. Attack again. Hits. Go up here. We attack, and our slimes get defeated. Okay, so in the interest of time, I think this is a good stopping point. Obviously, next steps would be making it so that when your slime runs into the player, you can deal some damage to the player, possibly upgrading the health of your slime and then adding in those damaged states whenever it takes damage but not defeated, and allowing the slime to move around in some way. You could either give it a random pattern or have it try to move towards the player position. But of course, as a crash course in learning how to create a top-down RPG, I think this is a good start. So hopefully all of you enjoyed this really long video in creating a character, allowing it to move around, collide with objects, deal damage to slimes, and setting up the tile map in general. So I've been Chris. Thank you for watching, especially to the end. And hopefully I'll see all of you in my future Unity content as well.